Okay, and I think thank you, everyone. And as Joanne said before, if anyone wants to interrupt, that's fine by me, including the people online. And it's not going to go, is it? Just use the end. That's what I was trying, but no. Okay. Yes, great. Okay, just some acknowledgements first. What I'm talking about today is a village has prepared it. So there was Laura, who was my learning designer, Matt, who worked with me in the unit, and Rani, who's one of our education specialists. Very sadly, Laura and Rani have now left our university, so lost them. Okay, so today I'm going to tell you a little bit of background about my course. Some reflections on the past assessment. I'm going to talk about one of my new assessments and some ideas on whether that was a good idea or a bad idea, how it worked. So I take first year engineering maths at RMIT. This is core for all first year engineering students. I think we've got about a dozen different types of engineering. And we have really, really large enrolments. This year, we nearly got to 1,300 in first year, which is a bit of surprise, and they expect it to keep increasing for the next 5 years, at least the next 5 years. In semester 2, it's still growing. We have currently, I think it's 452 yesterday. We don't start for another week and a half. I'm thinking it's going to get to about 600 students. So I've been there for just over 2 years. When I started, the first semester was just a fraction, I think 3 students under 1,000, to give you an idea how it's growing. And we cover calculus, differential equations, complex numbers and vectors. And when I took on this unit, it had the following assessment. It had, I think it was 10 quizzes, like a weekly quiz that occurred in most weeks. It had assignments. It had assignments that were called class exercise assignments, and it had a huge final assignment, and it had 2 tests. And the topics that we covered were done in parallel. So all the assessment wasn't driven by a topic, it was driven by where we were in the calendar, right? So it'd be like class exercise 1 will cover material from weeks 1 and 2 or something like that. And it was very unclear to students where weeks 1 and 2 were going to start and finish. On the other hand, the students, maybe step back. All the material was basically pre-recorded lectures. And then they had Q&A in class. And when I said nobody came to class before me, that's an exaggeration. They said you could count on the fingers of one hand how many students turned up for class. So that's the course I took over. Feedback from students was the recorded lectures were really good. So we left those untouched. And basically, I changed lots of other things in the course, of which I'm not going to describe all those things to you today. But one of the things we did, first thing we did, Joanne, I think it was, we redid our course learning outcomes because they were really, really topic focused. And that's where a learning designer comes in really, really handy because they help you move them into focused on words like they can utilise things, they can apply things. In fact, I brought my screen up. I just mentioned the key words we moved from, rather than having, we will cover vectors, we will cover functions, we went to identify properties that we can use to do things, utilise functions and to solve common problems in engineering. I'm skipping some of the words. Make connections between your problem solving and the solutions for engineering problems, analyse, and the new one that was totally new, that bore nothing in common with the previous ones, was communicating your conclusions and mathematical evidence for solutions to a range of audiences, which is key to what engineers have to do. Anyway, so what did we do? I like to think we merged our quizzes and assignments into some new types of assignments, and I'm not going to talk about those today, but they were aligned with the topics that were covered. So it was more visible, and also within inside of those, they were aligned to different expectations. The tests, we actually kept our tests. Engineering were keen that we keep the tests for authenticity and for integrity, but we've moved our tests on campus in class. And we created the new problem solving practical. That was our new piece of assessment, and that's what I'm going to talk about today. Okay, so some observations. We want to have assessment that's authentic. We would like students to actually collaborate. I can remember one thing I learned from a learning designer quite early as a lecturer. She said students learn faster when they construct learning together, right? And actually we work together. So we want to collaborate, and it's got to be something to do with engineering. So I think I've written something. Okay, so authentic. So it should include real world problems. Now, I think when I'm looking at the assessment that was in my unit, the real world problems were real world scenarios, and they were wrapped like a story. Wrap a maths problem into a story. The students unwrap it and get it back to the maths problem, and they solve the maths problem, okay? I think that's what often in the past we've had as a real world problem, but it doesn't actually incorporate the physical part of the problem. They don't actually touch and handle anything, right? Collaborative, as I said, maths is collaborative, but assessment is often individual. Yeah? And alignment to engineering graduate capabilities. This is just my experience. I'm sorry, it's not a very theory-oriented talk, but in my experience, students often fail to recognise when they have capabilities, and even if they recognise they have them, they have trouble evidencing them. I can remember, for example, we got some feedback from industry, and they said the students weren't able to evidence problem solving and critical thinking. It's like, we are failing if the students are failing to do that. So what I did was I just had a look at, I think it was in Grad Connections, which is a subsidiary of SEEK, and had a look at some of the things they were asking for graduate engineers. And these are the sort of jobs that I want my students to get, right? If they get a graduate role in a good company, they get, they get rotated around the company, they get a mentor, those sort of extra things. That's what I want. And look what they have. Well, this is like collaboration, problem solving, creativity, modelling, analysing data, analytical, initiative, solving difficult problems, problem solving. These are just cut and pasted out of the job ads, and these are maths, right? So I wanted in my assessment to link to that graduate expectation. The second thing I should say, so these are just my reflections, students often fail to think about the outcome of applying for a job early enough in their industry, in their university career. And I wanted my students to start thinking from year one, about becoming work ready. And so what do? We have a problem solving practical. It has a hands-on element. It has two assessment tasks, if you like. The first component is an in-class group component, and the second part is a reflective component. So what do they have to do in the group component? They have to create a mathematical model to predict the height of water in a leaking tank. Okay? So we have 5 things we want them to do. We want them to brainstorm with their group. We want them to create a model. We have some questions to investigate the behaviour of their model. That's their model like this, right? Not their model with specific values. So what happens when your radius R doubles? What happens when the height halves? What's going to happen? What do you expect to happen using your mathematics? Then we actually get them to apply their model to predict the height of water in a leaking bottle. Now, I'm really sad. On my table at home, I've left my bottle I meant to bring today. So imagine we got those 2-litre soft drink bottles, the Pepsi lemon ones, you know, that are pretty straight, so they're reasonably cylindrical. My husband then got his drill bits and drilled different size holes in the side. We stuck paper tape measures on the side because we don't have a budget for doing this, right? This is really cheap, you should see. So we ended up with all these bottles and they all had different holes in the side. We have, as I said, a large number of students. We would have between 250 and 300 students in each class. This is chaos, okay? But it's okay. It's okay chaos. To start with, you know, they come in a group. We usually try about a group of 6 and they can break their group up. We try and get them getting one of their group or usually 2 of the group to go and start measuring the water. So this is about, you know, thinking about how to use your group wisely. And we have a number of markers who just circulate around the room and they go up and down and up and down. Show us where you're at. Are you stuck? Here's a hint. So this is not like your traditional assessment. It's not a test. We don't say, oh, well, you're stuck. That means you're not going to get any further. We give them the hint to keep them moving. The penalty if you get stuck is that you're not going to finish all 5 pieces, right? But we never want somebody just stuck on number 1 and not moving along any further. Okay? Yeah? No? No, sorry. So the staff keep, every time they pass them, say, show me what you're doing. And we have a really simple rubric, right? It's either ticked off, you've done, you're partially done, half marks, or you're not there, you haven't started it yet. So each time you're seeing you go around, your marker ticks that one off if it's done. They tick it half off and give you some feedback if it's not fully done, and you can do some more on that and get it remarked as they come around next time. And as I said, if you're getting stuck on here, they'll give you a clue and you can start working with that and they'll come back around and do the next clue. Okay, so typically our markers would have at most 10 groups in a class, the 2-hour class, right? They just rotate round and round and round. So brainstorming, we expect them to, you know, draw a picture and define their variables and their functions and the domains and things like that. And we're giving them the message that drawing is part of maths. It's a model, right? It's the most simple model. Then they do the calculus. This is actually quite nice to my class because they have to use implicit differentiation. They've got a simple separable DE to solve, you know. They go, is it all right? Is it all right if we use their calculator? It's a really, really nice problem because the people that use their calculator stuff up G being for gravity and they get the wrong answer and they don't know why. So they're learning back to up here, you know, did you set your variables? What's a variable? What's a constant? Even, I don't know, you can't see at this stage, but I certainly sometimes get students that think pi is a variable, you know, so they're learning that as well. What else can I say? Oh, so then we get them to fill in the table. So we have a table here, you know, what does your model think and what do the people measure happening with the model? And actually, it's awful. The students are horrified because it's not the same. And there's this, there's all over the class, there's, oh no, what have we done? And that's fine. What have they done? Sometimes They've got inconsistent measurements. They've put in gravity measured in metres per second squared, and they've measured the radius of the bottle in millimetres and the height in centimetres, right? Oh no, measurement is important, right? Really, really important. And that's a really, really good way when they're absolutely panicking. They're like, it's not just a little bit out, it's a lot out. Well, let's look, let's go back, right? And that's a learning experience. The second is, it still doesn't match. That's actually the real world, right? When you abstract something to a model, you take away some of the details and it isn't exact, okay? So this is all right. We're teaching them that the real world is a messy place. The next thing we think about, there's the final question, question 5, is about thinking about what are the limitations of that model. And it's really easy. There's some really easy ones, right? The tape measure we've stuck on the side of the bottle, it's only in centimetres, I think, from memory. Wish I'd brought them a bottle with me. I usually hold up the bottle to give them a hint, and I go something like, oh, you know, my husband did a dreadful job with the drill on this. It's not even circular, and it's all rough around the side, so the area of the hole isn't round. The bottle doesn't go straight up and down. It has like a slight flex in the middle. So it's not a cylinder. So all of these are going to introduce inaccuracies. But in my unit, we actually learn about, you know, what happens if it's out by so many centimetres in the radius? What's the error in the function, given there's an error of at most this in the radius? So they already have the tools, and we link to the fact, we don't expect them in class to go and solve the error, but we link to the fact that they have those tools to manage those errors. And I claim that developing this understanding on how to deal with inaccuracies is essential in engineering. So I think that's quite a nice task from that point. Okay, so some reflections. Well, my first reflection is it's absolute chaos, right? We're doing what we can with an enormous class where it shouldn't work, right? It's just too big. But that's okay because we've got a more relaxed rubric, and my students usually do better in this activity than they do in some of their other assessments, right? So this activity actually is not only the only time we interact during an assessment in a face-to-face manner, and so can actually spot what's stopping students learning in a really real way. I forgot the other thing I was going to say. Anyway, one student got really excited, and he's like, this is what real engineers do. They fill water in bottles and measure the water colour. No, they work on problems together. And I thought that's something I don't remember ever doing in maths in my own degree. Some students have trouble with the maths, right? You can see how weak their maths is. You know, and because it's a leaking thing, they start looking up mixing problems. They're like, oh, we did mixing problems. It must be a mixing problem. No, it's not a mixing problem. Or they ask ChatGPT or whatever. But the thing is, we're no longer got that closed book, and we're no longer, it's like, I keep saying it's not like an ordinary assignment, and it's not a test. I actually took part in PROP, that's what's it, peer reflection and observation program. And they observed me taking a normal class and gave me feedback. And then I asked Rani, who was the head of the PROP program, if she could come and observe this new assessment we were doing and give us some feedback. Right? And it was interesting because Rani was a little bit like, oh, maths, you know, what is it like? Yeah, maths. Yeah, but she kept saying, she said this, I'd never seen a maths unit where every student was engaged, but they are here. They're all looking. She said, you've got people lying on the floor on their stomachs with their hands like this. You've got people measuring, you've got water. And she said, everybody is engaged. She said she couldn't believe it. So that was a good thing. But as I said, it was logistically challenging, right? And we've tried some things. One of the things, as I said, we have a very simplified rubric. And I tried this. This needs more work. So what we tried to put some extra scaffolding with Mentimeter, trying to encourage students that they could also ask questions on Mentimeter and could answer from the front. Because you can imagine we've got people coming around in a circular way, but that worked less well. Okay, so that was part one. Part two, this is the individual part. Okay, so we have two reflections. The first reflection links what they're doing to graduate capabilities. So what we asked them to identify the mathematical tools and techniques they found to solve the problem and justify their selection, right? Had this problem, and we're pretty easy on the justification. Students will go something like, well, I thought it was probably going to be a differential equation because it's a rate of change, if something is changing or something like that. So things like that, we tend to go, oh yeah, well, that's a good attempt at giving an example. So this is what we asked them to do. What did you use? And justify your choice. Sometimes the students get a little anxious because they're like, it mightn't be the best thing. And I said, but actually, when you're out working as an engineer, you have your toolbox of techniques and things, right? Think about your mathematical toolbox and you pick the best thing that you have access to do the job. And then you've got to justify. I've decided we're going to use this approach and this is my justification. So I said that's something that engineers have to do. Now, we gave names to some of the things that remember I looked at the graduate engineering jobs and some of the things we gave names: problem handler, reasoner, communicator, questioner, work planner, note taker, modeler, data handler. These were words that they were roles that we gave to different attributes that genuine big companies are looking for graduate engineers. And we asked for the second reflection, we said, okay, we want you to identify one of these roles that you took in the group and describe one contribution you made in this role and the impact of this contribution. Okay? This was a role I took, this is something I did, and this was the contribution. Okay? So think about it. Maybe you're the person that's handling the data. Maybe you collected the data and you put it in a table and displayed it as two graphs to compare them. And you identified that was a big problem. And, that impact was you went back and improved your model, right? But this is exactly short and sweet. I should say both of these are only 150 words max. They're really quick to mark. Both of these things are things you need to do. Imagine you're at a job interview and somebody goes, give me an example of where you've been a problem solver and what was the impact of that. You can't give an essay. You need to be able to trot out, I did this and the impact was that, right? Okay? So this is saying to students, you need to be able to recognise when you've got work-ready skills. You're picking up problem solving, critical thinking, and you need to be able to think of a quick, simple example of how you can evidence them. Short and sweet. I should say, this is actually really hard for first-year engineers, right? It's really hard for first-year engineers. Yeah? But all the more reason to start them on early, right? So as they're going through their degree, they're thinking, oh, that's something that I've already got and it relates. So most students can say what they've done. In fact, unfortunately, they often say too much. Instead of just saying one thing, they go, I did this, and I did this, and I did this, and I did this, and I did this. And it's like, okay, you haven't answered the question properly. In fact, they get marked down from bench, and we warn them in our Yeah, we warn them in the announcements I send out before you start this. One thing, one role, one thing you did, and one, right? So, because otherwise you end up, and we stop after 150 words. So sometimes you go, I did, I did the whole lot. The rest of the team sat and watched me, right? So they've got to say what they've done. But outcomes and impact, they find hard. They either omit them or they're really vague. But it is necessary for a work skill, right? If you don't say what you've done, if you didn't say what you've done, then somebody else will take the glory, right? I give them the example because it makes them laugh. When I was doing my PhD, I had the office right by the kitchen and the fridge was putrid, like this smell come down the hallway, right? So one day I came into work early and emptied all out the fridge and I scrubbed it and da-da-da. When I came back at morning tea time, somebody else was taking all the thanks for doing it. I said, so if you don't, yeah, so they laugh. That's the thing, because it's like, it's practical. So they need to be able to do it, but they find it hard. So what we did, we introduced a class exercise in our, so this is our problem solving practical, but we have a practical class every week. And we introduced a class exercise. And what I did, I just asked ChatGPT the question from the assignment and got it to answer. And then we go and say, okay, does it say the role? Does it say what they did? Does it say the impact? Is the impact like, and it's quite vague and flowery, right? So that they can start getting an idea. So we introduced this to give them some help. So what can I say? So this is our problem-solving practical activity, and it gives students a chance to create their learning together. So they're creating their learning together to demonstrate graduate engineering capabilities and skills, and linking to those so that they're aware that we're learning those, and also explicitly linking these with our course outcomes and a mathematical, we can't even see the last word, mathematical skills. So I should say, we knew this was a nice activity because when we said, what of our course learning outcomes does it align to? It aligned to all 5. And that's really nice. You know you've got a nice assessment when you go tick, 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 tick. And I think that's all I've got to say. Thank you.
Thank you for giving me a nice little example to put on my filling of the maths for about authentic activities.
Do I pass?
Yes, this one's nice and high up on various scales. Well done.
It definitely needs improvement and it's definitely chaotic on the day.
Is this an end of semester task?
Yes, we do it. So in my course, we actually have week 1 to 13. Week 7 and week 13 are tests, in-class tests, and week 12 is the problem solving practical. So all course material is finished by week 11. Then in week 12, we pull all our calculus stuff together by our problem solving practical. And then week 13 has test. Yeah.
And sorry, I think you might have said this, but I forgot it. What was the size of the group?
Size of group 6 we did this year, just because we used to say 5 or 6, but because we have so many students, we do groups of 6 now. But what we do, this is new this semester. So most of this talk I gave last semester at WIM6, so it's sort of a bit, but this semester we actually got them to nominate 2 people who go off and start the measuring. We called them measurers, and they started the measuring activity. And so 4 of them were working on the brainstorming, while the other 2 were getting the water measurement happening, because there's a lot of students. If you've got 300 students and you break them into groups of 6, that's 50 groups. And we had 4 or 5 markers in the room, plus the lecturer, plus some of their, and most of them I had a new, what's it called, career teaching academic, you know, that's just new early career researcher, and they would come in and they were watching, but they got into it as well. Yeah. So it is hectic. Yeah. So any suggestions that help practically?
Sessions you have?
We have 5 sessions. So you've got to realise we have 5 sessions. We have 2 of them have nearly, I think, 299 students in or something, which is the capacity of the lecture theatre. And then one of them, the 5th session, was about 75. It's like our overflow session because...
So 299 in one room doing activities.
Chaotic. That's what I'm saying. It's chaotic. Yeah. But we don't have teaching spaces that do this. So we just have to make do, right?
What's the space?
In our tiered lecture theatre. Tiered lecture theatre. That's why I'm saying people are on the floor. We have people, there's like a big flat entrance up the back. So we had all the measuring occurring up there with somebody just observing, like crowd control. Like they literally, I had one of my newer sessionals and they sit up the back and make sure that everyone stays orderly. We have about 10 bottles, I suppose, 10 bottles and a bucket and 2 basins and jugs of water for them and towels, which worked out well because my office flooded the other day and I had the towels on hand. Yeah, so it's chaotic, but I think it's worth it. The marks they get in this are a little bit better than their test marks, so it pushes up a bit. We have a nice mix in our assessment of some things that are easy to get some marks and some things that are really hard, which means we have quite a low HD rate and we have reduced the numbers of fails. So we're starting to look more normal. We're not looking normal, but when I took over, it was like, just a block. Yeah. So, it's not ideal, but we do what we have with what we can. So any suggestions are really helpful. The simplified rubric with the learning designer was a big help. I think it aligns well with what we wanted. Yes?
You haven't broken or damaged any students in the process, have you?
Nobody's been broken yet. Yeah, and interestingly, because we're just doing our assessment review in engineering, so I'm in maths, but I'm part of the engineering assessment review, and it said, are your activities suitable for diverse and inclusive, etc.? We've been doing this 2 years now, and that's 4 iterations, and we've only had 1 student that asked for an alternative assessment. Only 1. So, and I have students that have scribes and readers and things like that, but they're not asking for it. They're coming along to this activity. They're bringing along somebody extra with them. They've just they haven't even contacted me. They've just organised it all themselves. So compared to the test where they have single rooms or a room on their own or something, they're just coming to this one. So I don't know why that is, but that's what's happened.
How much is this worth?
It's worth 10%. Yeah, 10%. So we have 5 topic assessments, each worth 10%, but my topic assessments are broken into minimum standards, which are worth 50%, and then intermediate maths problems and an extension problem. And each they can only do when they've finished the one before. So we get fewer students doing each level, right? So that reduces our marking time a bit. They've got 5 of those, 2 tests worth 20% each. Typically they do a little bit worse in the test. They do very well in the assignments. What a surprise. We're working on that as well because for their core skills, their pass level, they can do it many times and it's auto-marked. And then they submit what we call evidence that they did it. So they submit their evidence and their evidence is marked. We don't mark that for correctness. It's just showing that they did it themselves. So that's to try and reduce, if they feel like they have multiple attempts, hopefully they don't feel the need to cheat.
What does the evidence that they did it look like?
So this will be, you imagine if you were doing a online assessment with, say, calculus problems or differential equations, and you wouldn't be writing them out really neatly, but you'd be, you know, doing the differentiation and some scribbling things. So it's literally that scribbly work that, what is it called? The chicken feed, that as they're doing it to get the answer, we don't expect neatness for that. They do this. And as well as that, when they submit that, they're asked, and they don't know what the question is in advance, but they're asked a very basic short answer question that they can just answer. And we do that. I keep telling my markers, we're marking it for hearing the student's voice. If it's okay, give them it. Give it, because what we're doing is we're learning the student's handwriting, we're learning the student's voice. So the marker will start saying, oh, that sounds like the sort of answer from so-and-so, you know, that becomes their individual thing. So we use the short answer question. It could be like, what would you use vectors for in your area of engineering or something like that? So we're really, it's not about the concept, it's about learning their voice and so getting a bit of an idea of the individual. Thank you.